Welcome back. This is Joe Samo from San Diego. I've had a few GMAT students ask me about this particular data sufficiency question, so I thought I'd do a quick video about it. What is the cube root of W? And remember, in the data sufficiency, you have two data, 1 and 2, and the answer is A if data number 1 is sufficient to give you the answer only. B is correct if data number 2 is sufficient to give you the answer. C is correct if you need both of them to be sufficient to give you the answer, but one of them alone is not sufficient. D is the answer if they are both sufficient alone. And E is the answer if neither of them are sufficient and they're not sufficient together to get the answer. Give this one a shot on your own, and then we'll do it together. All right, I hope you tried it on your own. Now let's do it together. What we want to know here is what is the cube root of W. So we want to know what is W to the 1/3, right? W to the 1/3 is the same thing as the cube root of W. So that's what we need to know. Data number 1 gives us that the fifth root of W is 64. What that means is W to the 1/5 equals 64. Okay, but what we want to know is what is W to the 1/3, right? So what we can do here, well, there's a few ways we could do it. Well, the way I did it was I first raised each of these to the 5th power. All right, so I raised W to the 1/5 to the 5th power, and then I raised 64 to the 5th power. It's okay to do that. You can, instead of like squaring each side, I'm just raising each side to the 5th power. So W to the 1/5 to the 5th power, you just multiply 1/5 and 5. So that would be W to the 1. And then the other one is 64 to the 5th power. We could just leave it like that. We don't have to solve that or anything like that. But what we want to know is what is W to the 1/3, right? So now what we do is then we can take the cube root of each of those. So we would take then the cube root of W, and then that would equal the cube root of 64 to the 5th. And that's the answer. So the cube root of W would be the cube root of 64 to the 5th, or also it's the same thing as saying 64 to the 5/3, okay? It's the same answer. So, boom. So that one is sufficient. All right, so now let's do number 2 real quick. Number 2 says W to the 1/15th, right, which is W to the 15th root, equals 4. What we want is W to the 1/3, right? So if we have W to the 1/15th and what we want is W to the 1/3, we would take W to the 1/15th and we would take that to the 5th power, right? Because then when we're going to multiply 1/15th times 5, we're going to get W to the 1/3, right? And then that equals then 4 to the 5th power. All I'm doing here is I am taking each of those and I'm taking it to the 5th power, right? So now W to the 1/15th to the 5th power equals W to the 1/3, and 4 to the 5th power equals 4 to the 5th power. That looks a little easy, but that is the right answer. So that one is sufficient also. W to the 1/3 equals 4 to the 5th power. Just as a side note on both of these, whenever you get something like W to the 1/15th equals 4, you're going to have a definitive answer for W. The only time you don't have a definitive answer is if it was something like W squared equals 10, right? W squared equals 10, then W could be a positive or a negative number. But when you have it, 1/15th, then you're going to have some sort of definitive number for W. And as long as you have a definitive number for W, you could definitely get a definitive number when you take the cube root of it. These ones are both sufficient. So if they are both sufficient by themselves, then the answer is D like David. All right, keep up the practice.